today's class, superposition theorem. The concept behind superposition theorem is that just that the principle you are learning now, anything you are learning now, that's what you'll be applying for several questions as far as superposition is concerned. You can use different methods to solve your circuit, but you might have a question whereby the principle you have to use is called superposition theorem and you have to use it. So let's take down what superposition theorem states. Superposition theorem states that in any circuit made up of linear resistance containing more than one source EMF, full stop, the resultant current in any branch is equals to the algebraic sum of current in that branch if each source are considered separately. Consider this. Let's say you have this circuit. Alright, look up please. Let's relate that definition. Superposition theorem. What superposition theorem states? Let's relate it to this circuit diagram. Now, in your branch AD, I believe you know what a branch is. I've done videos on what a branch is. Alright, let's say this is E1 and this is E2. Meaning that this circuit now, we have more than one EMF, more than one voltage. And the voltage in this case are what? E1 and E2. From the statement of superposition theorem, it says that you are going to consider E1 first. Considering E1 first, which is the source EMF, you are going to have three values of current, right? When you consider E1. Now, considering E2, similarly, you have three values of current. Let's do an absorption. Considering E1, considering this first EMF, we got the value of I1 to be 0.2 ampere. We got the value of I2 to be 0.6 ampere. And we got the value of I3 to be 0.8 ampere. When I considered E1 first, I got this value, right? Now, considering this source EMF, each value, we have the corresponding value. Any question on that? I1 too, we have the corresponding value of I1. Similarly, we also have a corresponding value of I2 in that same branch. Likewise, I3, we also have a corresponding value of I3 in that same branch. That's what superposition theorem is saying. Now let's solve. You already know what the question wants us to calculate. The current in each branch, right? Now, solution. First thing first, consider one of the two sources. Is it E1? Now, by considering E1, it means that you eliminate this. You won't use this. You are withdrawing the circuit diagram, but not including E2. You understand what I'm saying? Now, let's withdraw the circuit diagram. Then it becomes this, right? We are repeating all what we have here. The only thing that we will include is what? E2. So from here I have this. This is, what do we have here? 4 volts. What do we have here? 2 ohms. What about here? 4 ohms. And the last one, 1 ohms. Then this remains A, C, E, F. Now, can you see what we just did? What was the first step? We are considering the first source EMF, and which is what? 4 voltage. Now, we drawing the circuit diagram. This is what we have, right? That's the first step. On step 2, let me ask this question. Your resistor, are they in series or in parallel? They are in parallel. You observe that you have 3 resistors here, right? Out of these 3 resistors, you have 2 standing on its own. Are you in it? You have 2 standing on its own. Meaning, there's a particular resistor in a branch with a voltage. Is it not? Meaning that for branch AB, you have a resistor, but the resistor is with a voltage. Now, for branch CD, you only have a resistor there. For branch EF, you only have a resistor there, right? In general, what it means is that when it comes to superposition theorem, after withdrawing your circuit, when you consider the source EMF to use, the resistor standing alone, you are going to solve them in parallel. Are you getting the idea? You are going to solve them in parallel. Let's say this 4 voltage. Let's say you have your 4 voltage here, and this resistor is standing alone. So tell me, what will be the resistor you be solving in parallel? Which one? 2 and 1, right? Why are we be solving 2 and 1 in parallel? So that's the idea. Okay, back to the initial question. So we have 4 volts, right? Knowing fully well that I'll get 3 value of current, is it not? I'll get 3 what? 3 value of current. Now, what you should note down is that in superposition theorem, when you consider the first source EMF, when you've completed the source EMF you are going to use, you also need to consider your direction. Are you with me? You also consider your direction. Now your direction, this is how your direction should work. This is where the direction is starting from. This is where the source voltage is coming from. You know, on getting to this node, what will happen? Let's denote this as I2. Should I use I2? Okay, let me clean this. Let's say the initial question, we have I subscript A, I subscript B, and I subscript C. These are the value of current I want to know. Now, solving, let's denote this as I1. Are you with me? Now, let's say that this is the source current from this voltage. On getting to this node, what will happen to this current? It will split, abi? It will split to this branch and it will split to this branch. We go from KCL. What does KCL says? It says that the algebraic sum of current entering a junction is equal to the current leaving that junction. Meaning that this I1 is the current entering this junction, which is junction C. Automatically, is going to leave junction C. And leaving junction C is going to split. Any question on that? Now, let's say that this I1 has splitted in this manner. Denote this as what? I2 and denote this as I3. What did I say earlier? I said in superposition theorem, we are considering parallel resistor. What should be the idea of the parallel resistor? What should be the interest? Which one am I interested in? You know, I have 3 resistors here, and out of these 3 resistors, I want to solve them in parallel. But which one should I pay attention on? The one that don't have voltage, abi? And in this case, they are what? 4 and what? 1. Now, recall from your parallel calculation of resistor. What's the formula? R total 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3 and so on and so forth. Also know that if it is 2 resistor, then R total becomes the product of the 2 resistor divided by the summation of the 2 resistor. Is it not? Now, what it means is that for this circuit diagram, you then have that your parallel resistor, you can draw it out, but there's no need of drawing it out. Since you understood the concept that you want to solve this and this in parallel, work it out. Meaning that R total parallel calculation of 4 ohm resistor and 1 ohm resistor. What do you have? What should we denote it as? Like the variable. We should use R, abi? Okay, meaning that R is equals to what? 4 times 1 divided by 4 plus 1. What's the value? 4 over 5 is equals to what? 0.8 ohms. Are you with me? Now, what you are doing is that you are reducing your circuit. From stage 1 here, this was the initial question. Implementing superposition theorem that states that we will be considering each source individually. Now, we considered E1, and that was 4 voltage, right? And this is it here. So this is our circuit diagram after considering 4 voltage. Step 2, solve the resistor that don't have the voltage in it, and that's what we did here. We got 0.8 ohm resistor. The next thing to do, next up, we then add this diagram attaching this 0.8 ohm resistor. Then this is how it looks like. Then you have something like this. This is R. R equals to 0.8 ohms. I want you to look at this circuit diagram. What will be the value of current? What will be the current? this is B, this is D, this is 4 volts, and this is, what's the value here? This is 2 ohms. This is also 2 ohms. Now I want you to look at this circuit diagram. Sorry, I want you to look at this circuit diagram. What will the current I'm going to indicate here? What's the current flowing through this circuit from this analysis? Look at it very well. You know, we reduce this circuit. We've solved this and this in parallel. We got this. We are still repeating everything that is here. But the only difference is that since we already know the equivalent value of this, that's why I'm representing it as 0.8 ohms. But from here, we have 3 value of current. We indicated 3 value of current here, which are I1, I2, and I3. Doing comparison between this diagram and this diagram, what will be the current that I'm going to indicate here? What do you call it? I1, right? From here, this is branch A, branch C, this is A, C, B, D. And that's what we have here. And from A, C, B, D, you are seeing that I1 is flowing through these branches. Similarly, you have I1 here too. Hope you are getting the idea. Any question? Now, what it means is that from this circuit, you can get the value of I1. How do you get the value of I1? We come from Ohm's law. What is Ohm's law? What does Ohm's law state? V is equals to what? Mathematically, we come from Ohm's law. Ohm's law states that V is equals to what? IR. We call this equation 1. From equation 1, make I the subject of the formula. What do you have? V over R. So to get the value of current here, which is I1, you are implementing Ohm's law. Now, what's the voltage? 4. What's the resistor? 2 and 0.8. Meaning that I1 becomes 4 divided by what? 2 plus 0.8. Then this is what? What do you have? What's the value? 1.43 amperes. Gotten I1 to be 1.43, right? But in this place, what are the value of current you are calculating? How many value of current are you calculating? 3. And they are what? I1, I2, and I3. But now, you've known I1. You are yet to know I2 and I3. Now, the idea to calculate I2 and I3, you use what we call current division rule. Current division rule. And the idea is very simple. Now, what I want you to do for me, applying current division rule, what's the value of current flowing through 1 ohm resistor? Look at this diagram very well. What's the value of current flowing through 1 ohm resistor? I2. That's it. Any question on that? Any question? The value of current flowing through I2 is what? Sorry, the value of current flowing through 1 ohm resistor is what? I2. What about 4 ohm resistor? I3. What about 2 ohm resistor? And we've gotten the value. We've gotten the value of current flowing through 2 ohm resistor to be what? 1.43 ampere. Now, how do you get the value of current flowing through 4 ohm resistor, which is I3? Likewise, the value of current flowing through 1 ohm resistor, which is I2. It's very simple. We apply current division rule. Just say current division. Now, current division rule, it is very, very simple. Current division rule. What you just need to do here now, let's say, you are yet to know 2 values of current, which are what? I2 and I3. Now, let's solve for I2 first. Are you with me? The resistor in question now is 4 ohms and 1 ohm resistor. Now, for I3, which one should we solve first? I2 or I3? I2. We want to solve for I2. What you should put in consideration is that what's the resistor of I2? That was what I was asking the other time. What's the resistor of I2? 1 ohm resistor. Meaning this is the resistor you are interested in as far as I2 is concerned. Are you getting it? Now, let's say you want to calculate I3. What's the resistor of I3? 4 ohm resistor. Meaning that you are interested in 4 ohm resistor as far as what I3 is concerned. Are you with me? Now, let's calculate I2. As that's what you guys said. Calculating I2 now, what it means is that the resistor of I2 is what? 1 ohms abi. If you are calculating I2 meaning 1 ohms, you are not interested in 4 ohm resistor, but that's what you are going to use here. Are you with me? The one you are not interested in, that's what you are going to use. The one I'm not interested in, between 4 ohm and 1 ohm resistor, which one I'm not interested in? 4 ohm resistor, meaning you have 4 ohms, which is the one you are not interested in, divided by that same 4 ohms plus the one you are interested in. Which one are you interested in now? 1. Multiply by the current of I1. And what was the value you got? 1.43. 1.43 ampere. Sorry, just 1.43. Let's solve this. What's our value? 4/5 multiplied by 1.43. What do you have? 1.1 1.144 1.144 ampere, right? Now same idea applies to I3. Are you with me? Any question on this? Because how you got I2, that's the way you solve for I3. Let me recap. When you are calculating I2, come to this diagram. This is I2, right? This is I3, abi. Now since I'm calculating I2, ask yourself, what's the resistor value of I2? 1 ohm. That's what you are interested in. What's the resistor value of I3? 4 ohms. You are not interested in that one. Meaning that you have 4, the one you are not interested in, divided by that same 4 plus 1, which you are interested in, multiplied by the value of current you got initially. Any question? Any question? That's how you arrive at this answer. Now how do we do this? Apply the same method. It will be what? 1/1 plus 4 multiplied by what? 1.43. What's the answer? 0.286 ampere. We've calculated the value of I1. What's the value of I1? So I1 is what? 1.43 ampere. I2 is what? 1.144 ampere, and I3 is what? 0.286. Now let's go back to superposition theorem. Let's see what superposition theorem states. Superposition theorem states that in any circuit made up of linear resistance, abi, and several voltage or several source EMF, the resultant current in each branch is equal to the algebraic sum of current that will flow in that branch if each source are considered separately. Now observe, meaning our initial question, we have 2 value of voltage, abi, 4 volts and what? 2 volts. Now we considered 4 volts, we got 3 value of current, abi. Now the next one is this case 1. Case 2, we will consider 2 volts. Are you with me? Meaning we are going to get 3 value of current as well. That is, for I1 will have a corresponding value of current. Any question? The same branch we got I1, we are going to get another current there. It becomes the corresponding value of I1 in that branch. Are we clear? Any question? Any question? Similarly for I2, the same branch we got the value of I2, we get another current there, and that current becomes the corresponding value of I2 for that branch. Likewise I3. Can you now see what the theorem states? Moving further, I'm still on that theorem. That theorem now states that, as we know that whenever I'm giving a circuit problem, I just need 1 value of current in each branch. I don't need 2. Now I'm getting 2 values. What does that mean? Meaning I'm going to sum the 2 values. Is either I sum or subtract. So if I'm summing up, that becomes the resultant value of current in that branch. Any question? If I'm subtracting, that becomes the resultant value of current in that branch. And finally, we've gotten the resultant value of current in that branch. And that's what superposition theorem is saying. That's the idea.
You said when you're adding the current together, that
Okay.
is the value.
Yeah.
How you are subtracting. So when you're adding, is it that the current is in the same direction?
Yeah, we get there. It's when it comes to addition and subtraction, there is what you need to consider, what you need to look at before adding and subtracting.
So let's look at the other.
Yeah, let's look at case 2 now using 2 voltage.
Yes.
All right, moving on. Now for case 2, by case 2 we are considering 2 volts, same idea, nothing is changing. The approach we used to solve the first one, that's what you are still using, you are just reversing it. All right, now we used for the first one, we denoted the current in each branch to be I1, I2, I3. Now let's continue from there. Although is your choice, you can denote it with any current value, even though you can use IA, IC, as far as you understand the concept. Now for this one, I'll be using I, I4, I5, I6. Now, what you need to take note is that for that one, the source current is coming from 4 volts. You know, this was the, if you recall, this was the diagram for the first one. We have it like this. We have 4 volts here, meaning that I1 is starting from here. The source current is coming from this 4 voltage. Then on getting here, it's splitted. Same idea. The source current will be starting from 2 volts here. Are you with me? The source current will be starting from what? 2 volts. That is, I have my current flowing in this manner. Abi, it is starting from 2 volts. It's going like this. Don't forget that this is a node. What do you know about a node? When your current gets to a node, it's going to what? Split. Abi, meaning that CA, the current will split. Let's denote the source current as I4. Let's continue from where we stop. Denote it as I4. On getting to this node, then I4 splitted into 2. It's splitted to this branch CA, and it's also splitted to this branch CD. Then let's denote this as I5 for, which one should go for I5? This or this? This should go for I5, Abi. This is I5, and this should go for I6. Any question? No question. Now, what was the first step we implemented for case 1? We can recall. We said, what do we do? Check, observe the resistor that does not have voltage. Now, check. Which resistor is standing on its own? 2 and 4. 2 and 4. 2 and 4 does not have voltage in their branch. Abi? What does this mean? Solve them parallel, because they don't have voltage in their branch. Solve them parallel. By parallel, meaning that the product of the 2 resistors divided by the sum of the 2 resistors. Alright? You should denote it as what? R. Okay, solving 2 ohm resistor parallel to 4 ohm resistor. We denoted the equivalent value. We are denoting it as R, meaning that R is equals to 2 times 4 divided by 2 plus 4. Right? Then this is what? 8 over 6. What's the value of this? 1.33 ohms. Step 2 is what? What will be the next step? We draw the diagram, the equivalent diagram. Okay, we are reducing this diagram. Then it becomes, I'll be representing 2 ohm resistor and 4 ohm resistor as this equivalent value of resistor. Abi? Then I have this diagram. What will be here? Nothing is changing. What is changing is that you've solved the equivalent value of 2 ohm resistor and 4 ohm resistor to be 1.33 ohm resistor. So you are reducing it. Then for this place, you have the value of R, which is what? 1.33 ohms. What do you have here? 2 volts. What about this place? 1 ohms. Then the branch, that's C, E, D, and F. So when you are solving any circuit problem, it's always advisable to label your circuit diagram. You understand what I'm saying? it's always advisable to label your circuit diagram for easier calculation. Now my question is, from here I'm having three value of current. I indicated three value of current here, which are I4, I5, I6. Doing comparison between this diagram and this diagram, what will be the value of current that will be flowing through this circuit? I4. Any question on that? Any question? No question. Meaning, in what manner is I4 flowing? It's flowing like this, abi? We have I4. Any value of current I have here, it becomes the value of what? I4. Is that understood? Recall from Ohm's law. Ohm's law says that voltage is equals to what? IR. That is, I equals to V over R. Then I4 becomes, that will be what? 2 divided by 1 plus 1.33, which is equals to 2 divided by 2.33. And this is equals to what? 0.86. 86 ampere. Alright, what's the next thing to do? Next step is what? Let's stop. What are we doing? Current division rule. Why am I using current division rule? Because I'm yet to know the I5 and I6. And how do you go about it? Implement current division rule. And what's the idea of current division rule? Current division rule says that make use of the resistor value of current you are not interested in. Abi, with the one you are interested in. Now let's apply current division rule. We also have voltage division rule, but for current division rule, then what's the next step? Use the current division rule to get the value of I5 and I6. Now let's solve for I6. Let's solve for I5. Solving for I5, what do we have? I5 equals to, open brackets,
the I5. What we need is 2 ohms. So what we need now is going to be 4 ohms.
Okay, what we need is what? The current of 2 ohms, which is I5. Yes. But the one we don't need is what? 4 ohms resistor. So we are using it. Yes. Then it becomes 4 over 4 plus 2, okay? Yes. Close bracket. Times the 0.86. The value of I4, 0.86. What do you have? Input this in your calculator. What's the value? What's the value? 0.57. I5 0.57 ampere. Alright, now let's solve for I6. What's the value of I6? Same idea, nothing is changing.
Yes,
that what?
For I6, the resistance that we need is 4.
4, okay?
What we don't need is 2
ohm resistor. Then what do you have? 2 over 2 plus 4 multiplied by 0.86. Then this is what? What's the value? That should be 0.286. 0.286. Don't forget your unit though. 0.286 ampere. Any questions so far? No question. Hello.
Yeah. My question.
Yeah. What's the question?
My question is according to the superposition theorem.
Yes.
That both the I2, I3
okay.
is going to correspond with I for I5, I6.
Okay.
In the situation we have now, is the I3 and the I6 that correspond.
Okay. Oh. It corresponding in the sense that their value is not as if their value will be equal. Okay. Corresponding in the sense that in each branch we have 2 value of current. Are you with me? By the corresponding that saying that I1, check branch AB for case 1. What the current we got here, we denoted this as what? I1. Now what will be the corresponding value of current here? I4. That's it. That's what you are saying. I1, I4. Abi. Now for branch CD, check for case 1. What do we denote the current as? I2. Now check this one. I5. I2, I5. The last one will not be what? I3, I6. So that's where the resultant value of current will now come in. You know, initially we said the resultant value of current that would flow in each branch is equal to what? The summation of current in that branch if each source are considered separately. Understood?
Yes.
That's it. Now, you now observe for I1, for the first one, what do you have? I1 and what? No. I1 and I4, Abi?
Yes. Yes.
I1 and I4.
For branch 1.
For branch AB, for branch AB.
I1.
I1 and what? I4. Now, to now get the resultant value of current now, but the priority now is, are they going in the same direction? If they are going in the same direction, it becomes addition. If they are going in different direction, subtraction. Are you with me? Any question? So what that means is, what that actually means is not as if you just add and subtract. It is called superimposing. Yeah, that's what it means. So superimposing, yeah, that's it. It is spelled SUPERIMPOS. You are going to draw your diagram. After all this now, you've gotten the value of current for everything. Now you will now superimpose. By superimposing, you are drawing the two circuit diagram for case 1 and case 2. So it will now show you the direction they are going. If they are going in the same direction, add. Opposite direction, subtract.
For I1 and I4 now going in different direction.
Well, it will now be what? Negative. So let's see. Any questions so far?
Yeah.
Question?
Yes.
Alright. No, you see that now. Aside from direction, what else? You see that. What of this? I5 or I6? Okay, I5. And this one is what? Hope you are not convinced about the diagram. For this one is for case 1. This diagram like this. This is for case 1. Then the broken line is for case 2. So this concept is what we call superimposing. Superimpose. You superimpose your circuit. By superimpose, it means draw your case 1 and case 2 the same thing. And what you are actually doing here is to check out for the direction. Now from here now, what can you observe from this circuit? We are using branch now. For branch, or better still, let's use resistor. Abi, what is resistor here? This is 2 ohm resistor. This is 4 ohm resistor, and this is 1 ohm resistor. Abi, now check out for the current. Check out for case 1. Check out for the value of current. For case 1, it is what? I1. Now for case 2, check out the value of current of 2 ohm resistor. No, I don't want to get this thing complicated. This diagram now for case 1 now. Let's solve for 2 ohm resistor first. For 2 ohm resistor for case 1, what do we denote the value of current? What do we denote the value of current? I1. What about case 2? What do you denote the value of current? I4. Now, are they going in the same direction? No, they are going in opposite direction. So therefore, what we are all together. So therefore, the value of current in 2 ohm resistor, is equals to I1 minus I5. Any question? I1 minus I5. Oh, sorry, I4. This is case 1. This is I1. Is I5. You are getting confused with the diagram. I get where the confusion is coming from. The thing is that forget any calculation you've done so far. Forget all the calculation you've done so far. Now, what you should consider, or what you should pay attention, go back to your diagram. Your diagram for case 1, go back there. Your diagram for case 2, go back there. And what you are using is how the direction is being assigned to those diagrams, to those 2 diagrams. Are you with me? Now, so I'm bringing this diagram together. For the first diagram, you observe that branch AC, we denoted it as I1. Abi? For branch CE, we denoted it as I2. For branch CD, we denoted it as what? I3. Abi? That's for the first diagram. Now, for the second diagram, for branch AC, what do we denote it as? I5. For branch CE, what do we denote it as? For branch CD, what do we denote it as? So, go back to branch AC. We want to sum the current together. If they are going in the same direction, add. If they are going in opposite direction, subtract. Now, the question is, are they going in the same direction? No, it becomes subtraction. So we are not saying that the first current value, which was I1 minus I5. Ask yourself, by the time you subtract it, you get a value for current. Abi, that value of current is for 1 resistor. Are you with us? Yeah, you are agreeing with the 2 ohms. It's for 2 ohms. Any question on that? So what we said, by the time you substitute I1 and I5 now, you get a value of current. Abi, that value of current is for 1 resistor, 2 ohms. Why is it 2 ohms? Come back here. You have it like this. Abi, it's starting from here, and it's passing through 2 ohm resistor. So that's why I am denoting that the current of 2 ohm resistor is equal to I1 minus I5, and that's it. Any question? Now, before substituting each values, let's calculate the value of current for I4. That will be what? We will use this concept. That will be what? Don't forget the rule. If they are going in the same direction, add, opposite, subtract. Now, come back here.
I don't give you I2 minus I4. Yes, 4 ohms.
Now the I3 they are going in the same direction. I3 is in the same direction as
Now check for 4 ohm resistor. Check for 4 ohm resistor. I want to answer. For 4 ohm resistor, it will be what? Oh yeah. Okay, are we all concluding on that? I3, what about you? I3 plus I6. I3 plus I6. For case 1, 4 ohm resistor. Identify a 4 ohm resistor. What the current flowing through 4 ohm resistor for case 1? I3. Check for the second diagram. Identify a 4 ohm resistor. What the current flowing there? I6. Are they going in the same direction?
Yes.
And what do you state? If they are going in the same direction, what will happen? Add. Meaning that the current in 4 ohm resistor becomes what? I3 plus I6. Any question on that? No question. Now for the last one, that the current in what? 1 ohm resistor. That will what? Without thinking too much. That will what? I2 minus I4. Yeah, that's it. Now, I've been expecting this question, but you not asked me. None of you asked me. And the question is, when I'm saying minus, can we also revert the case? Meaning, if you are saying I1 minus I5, can we also say I5 minus I1? Hope you are getting it. Are you in me? Similarly, if you are saying I2 minus I4, can we also say I4 minus I2? The answer is no. Are you with me? The answer is no. Why? Because by the time you go with that, you might be getting your sign positive, negative. Exactly. Just know that this is the principle. And for any questions on superposition theorem, it remains the same. Nothing is changing. Nothing is changing. It remains the same. Any question under superposition theorem, as far as superposition theorem is concerned, this is what you implement. Now let's substitute each value. Substituting each value for 2 ohm resistor. Okay, first of all, let's list out all the value of current. I1 is what? 1.43 ampere. I2 1.144 ampere. I3 0.286 ampere. I4 0.86 ampere. I5 0.57 ampere. I6 0.286 ampere. Now let's solve for I2 ohm resistor. The current in 2 ohm resistor, what do you have? I1 minus I5, that is 1.43 minus I5 0.57, and this is what? What do you have? 0.6. Please calculate very well. 0.856. You approximated for me 86. Okay, if you approximate this in money, so 0.86. I don't know that some people love approximation. Okay, what is it? 0.86. What do you unit? Ampere. Don't forget, it's very important. Then current of 4 ohm resistor, what do you have? 0.286 plus 0.286. Then this is equals to 0.5572 ampere. Then for the last one, the current of what? 1 ohm resistor. That is equals to what? I2. What do you have for I2? 1.144. Negative I4 is what? 0.86. 0.86. Then this is equals to what? 0.284 ampere. So therefore, the value of current flowing through 2 ohm resistor is calculated to be 0.86. The value of current flowing through 4 ohm resistor is calculated to be 0.572. Likewise, the value of current in 1 ohm resistor is calculated to be 0.286. Now, any questions so far? Now, what you need to know is that. What's the question?
You get negative.
Yeah, for sure, very possible. It's possible. I have another example here. Of course, yeah, I have an example like that. But don't forget, I told you that the principle remains the same. You know, some question, I might choose question for you guys. Let's say you have the voltage being at the center, and you have one resistor here, one resistor here. First thing that will come to your mind, after considering the circuit, the source EMF you are going with, then the next thing is to draw the equivalent circuit. Abi? The next thing is to draw the equivalent circuit diagram. Now, if the resistor and voltage is here, you already know that you don't have business with that resistor. Your interest should be the one here and the one here. Meaning, by solving in parallel, you are using this guy, then you now bring it together. But I have similar example like that. Probably we can solve something like that. Right. So far, this is how you solve for superposition theorem. The principle remains the same. And relating all what we've done so far with the theorem, you can see that the theorem is perfectly correct. When we considered the source EMF, we got a value of current in each branch for the first source EMF and the second source EMF. Then after doing all that, we superpose the circuit diagram for case 1 and case 2 by comparing the direction. If they are going in the same direction, add. If they are going in the opposite direction, add. Then always note that case 1 minus, if both for case 1 and case 2, if they are going in different direction, always know that you have exactly subtract case 2 from case 1. Not saying case 2 minus case 1, it should be case 1 minus case 2 always. That's what you should take note, and that's what we've done so far. So this is called superimposing. This is how I spell it. Superimposing. Superimpose. Alright.